Alrighty, one thing I got to add to that glycolysis is that as long as these reactions are in the cytoplasm, okay? So glycolysis, being that glycolysis takes place in the cytoplasm, glycolysis is anaerobic. And anaerobic means without oxygen. Did the oxygen come in here and say, I'm gonna get used here? No, oxygen's like, if I got enough oxygen, I'm gonna go down there. So this is anaerobic respiration. So I'll just go ahead and put glycolysis. I don't know where to put that. Maybe I'll do green. Anaerobic respiration. A-N-A-E-R-O-B-I-C. Anaerobic. So let's add that to our little chart over here. No oxygen necessary or even needed. A-N-A-E. Anaerobic respiration. Boom. All right, so let's move on. So what's going to happen when this oxygen goes into the mitochondria? It's going to cause a series of basically domino stepwise things happening. And so that oxygen, it'll take place on all the cristae. I'm just going to go ahead and show that oxygen going to my cristae down here, because this is the cristae I'm going to be working from. O2. And your oxygen is, I'm just going to draw it over here. It doesn't go with this. I just need some board to write on. An oxygen molecule, that is molecular oxygen. Okay, it's gas. What it's going to do, it's going to break in half. You're going to have 1/2 of an O2 molecule. So those 1/2 of the O2 molecule are just an O. Just an O. You agree? Okay. Well, if you recall from the periodic table, when your O does not have a partner, he's looking to fill his valence. And since he's looking to fill his valence, he's always trying to collect some electron bonds. Does that sound very familiar? That's why he wants to partner up with himself. Because when he partners with himself, he double bonds and fills his valence. All right, so anyway, I just want to put that there because if you have 1/2 of O2 molecules, and you have several of them, I'm just showing you one of them. What's going to happen is you have a series of enzymes that are on this cristae. And these enzymes are going to be the electron transport chain, and the biggest, baddest enzyme in the end is going to be where chemiosmosis takes place. I don't want to draw them right now. It gets ugly. I don't want to draw them right now. But what the oxygen does, the oxygen will go to the cristae, and it will begin pulling on electrons, because electrons are going to travel in those enzymes and basically go from one enzyme to the next, to the next, to the next, giving off energy. So this half oxygen begins pulling electrons down the electron transport chain. Like, where those electrons come from? They come from this guy. This molecule, if enough oxygen is present, will get to enter into the mitochondria and go to the electron transport chain. Electron transport chain, where he will drop off electrons. And then this oxygen will become pulling on electrons. Because remember, these are high energy electrons. We need those. Glucose came with them. That is what will pull the pyruvates into the mitochondria, because pyruvates have some electrons too. And you'll see once it goes through the system, you'll be like, oh, I can see how those electrons are going down the chain. All right, so just wait on it. I will finalize it when we get there, no worries. All right, so here's our pyruvates. Pyruvate oxidation takes place in the matrix. Right away, when those pyruvates enter into pyruvate oxidation, there's two of them, 2 pyruvates. It was red here because it was the output here, but I'm making it the input here. So I'm just gonna go ahead and go like that, let you know, going in, boom. CO2 is gonna leave as cellular waste. 2 CO2 molecules, bye-bye. We'll exhale them. Okay? And then you're going to have some molecules coming in here. You're going to get 2 NAD pluses coming in. Sounds vaguely familiar. Those 2 NAD pluses will remove electrons from those pyruvates. Whoop. Thank you. He's going to get oxidized. He's going to get reduced, making 2 NADHs. You can see those 2 NADHs are carrying high energized electrons. Boop, boop. There you go. And those 2 NADHs are going to do the same thing. They are going to go to the electron transport chain where they are going to drop off their highly energized electrons. 2 ETC, electron transport chain. All right, we're almost done with this system here. We have a molecule going in. There are 2 coenzyme A. Coenzyme, E-N-Z-Y-M-E. 2 coenzyme A's go in. 1 coenzyme A for each pyruvate. Then those coenzyme A's are going to attach to the pyruvate molecules. Boom, boom. And then the molecule that is a result of this system is going to be called acetyl coenzyme A. C-T-Y-L, co-A. Acetyl coenzyme A. That's your final output of pyruvate oxidation. So pyruvate oxidation takes place in the matrix. And because this molecule couldn't get into the matrix without oxygen, all the systems inside the mitochondria are aerobic. Okay? Aerobic. A-E-R-O-B-I-C, which means oxygen is needed for that to happen. A-E-R-O-B-I-C. All of them. Bless you. All right. Go ahead and pause it. That was it. I'll go ahead and do the next one. I need a drink. I'm gonna need a drink. You guys are gonna have to reset that back up. You loving it or what?
Was it like ends it? Do you want that? Yeah. Okay.